Hi, this is David Lady again, and this is the first little short video going over the TrizIT patterns. These patterns are described in detail in the Information Technology System Cookbook. And the video here is just a chance to listen to my voiceover and look at a couple diagrams that explain, in this case, the very first pattern, the alpha pattern, that we'll go into in a second. This is material from the Information Technology System Cookbook, which, as I will often mention, is available on Amazon.com and can be bought with a single click. If you watch the little introduction video, this is the same slide, and this is a picture from the book. There's 4 different types of patterns. In the original Triz, these are called laws, and they're called the different laws of systems evolution, those types of things. They're not really laws, though. A law would suggest that it's so hardly written, it's written in stone in a way that is literally and easy to interpret. That's not actually the case. Really, these are more patterns. They're useful insights, just like anything in life. There are exceptions to them, but generally speaking, understanding and using these patterns in your system analysis is going to clue you into the quadrant that you're in and the types of solution models that you can use to solve contradictions within your system, those are some of the words we talked about last time, and some of the vocabulary in TrizIT and TrizIT. The pattern we're going to talk about today is the alpha pattern, the pattern of advancement in the direction of system ideals. This is really the overarching concept within TrizIT concerning systems, which is that they continue to get better, meaning they're more ideal. When they no longer can improve anymore or become more ideal, they tend to transition to a subcomponent of a larger system, a super system, to use our vocabulary, or they lose systemity, meaning they go away. The alpha pattern is the overriding steering pattern, and it provides insights, vocabulary, and some lightweight mathematics determining where a system is in its life cycle and the types of activities or the types of contradictions you'd expect to be resolving in the system to move it forward. So that's what we're going to talk about on the next slide. Everything in this pattern is based around this little graph, and this is the graph of increasing ideality. You can think of it in the same way in economics they have the supply and demand graph. The math is a little different. Directionally, we deal with these relationships a little different. But where where in economics you're dealing with cost functions, here we're really dealing with what we call value functions. What is the value of the system, and where are we in its volume-value relationship, which is what the graph discusses, and depending on where we are, it's going to drive us to the types of solution models that we want to look at to resolve any of the problems we're dealing with in the system. So again, this is the relationship. It's a volume-value relationship. We also call this then the value function. Generally, if you look at that first line, the cost and problems line, or a line, we would call it a curve if we want to stick to our economic concept roots. This curve tends to slope down, meaning that the more costs and problems a system has, the less value it tends to have. Makes sense. So on the left-hand side, where we're dealing with high volume in costs and problems, that's a lower value ratio than on the right-hand side, where we have a lower volume of cost and problems, and of course a higher value. Benefits tends to slope up. That's the light green line, for the same common sense reasons, which is where we have a low volume of benefits, the value of the system tends to be lower. Where we have a higher volume, the value of the system tends to be higher. So that's logical. It makes sense. That also gives us a cool little X to deal with. I'm going to look at and where the X comes together, we call that the value volume tipping point. I'm going to talk a little bit about that here. I'm going to add a line to the screen. So this little black line, I'm going to move it to a couple places here. First, when we're on the left-hand side of that value volume tipping point, that typically means that the system is struggling to emerge and become a viable system that is able to advance in a direction of ideals, right? So it's at a point where it's upside down, we could call it. The numerator, meaning the volume of costs and problems, is larger than, the denominator, which is the volume of costs and problems, is larger than the numerator, which is the benefits. So we're dealing with large numbers. Generally, if this is where we are with a system, if we score a system and we see that the costs and problems outweigh the benefits, an example I use is a silly example, but let's say that we build a website that will keep track of all of your passwords for you, because either you use the same password, which isn't very secure, or you have a lot of different passwords. However, the website has a problem which is not very secure. So the benefit of being able to have very unique passwords to all the things you have to log into, in one place where you keep it, is very high, right? So there is a benefit to that. However, if one of the problems is it's not secure and anyone can get to your passwords, then that system would be represented roughly by this black line, meaning that there are more costs and problems to the system than there are benefits for using it. So generally speaking, then, the solution models that we look for when we're in this scenario with the system are solution models that are going to either increase benefits such that we can get that numerator up higher, right, more benefits, or reduce the cost of the system or the problems associated with the system, such that, again, we can move and we can get that numerator so that it's bigger than the denominator. We can get more benefits from the system than the costs and problems associated with it. If I move the little line here to the middle, this is that tipping point I was telling you about. Generally, when we're doing system analysis and we're looking for solution models, we're looking to leverage the system now as it exists and finding ways to move it forward where we don't create any more costs associated with having the system. We don't create any more problems with the systems, but we can start to drive system benefits such that the benefits of the system will outweigh the cost of the problems. The last quadrant that we'll really look at here is a system that has a high value to volume ratio, where it has more benefits than the cost of those benefits or the problems associated with having those benefits. And when we're dealing with a system that's in this state, generally we're looking at a high demand for the system, and we're looking at ways to propagate this system and potentially even move it so that it becomes a specialized component of a larger system. That's really the end state of a system. So let's say, for example, that we're focusing on, back on that website that keeps track of our passwords, we build a system that is very, very secure. Well, maybe that security subcomponent of the system or subsystem can be used then and propagated in other systems that we're dealing with to deliver those same benefits. That would be the type of analysis and the type of solution models we'd start to look at inside of TrizIT when we analyze and we score our systems, so that we're in this left-hand quadrant. So we have systems that are on the left-hand side, where we're kind of upside down, and we're going to focus on solution models to either increase benefits or reduce the cost and the problems. We have systems where we're at that value volume tipping point in the middle, where we're going to then be focusing on, is there value to this system? Should we continue to move it forward? And then we're going to have analysis where we're in this right-hand column, where we have a valuable system that we're looking to propagate its use of and examine opportunities to move it into higher order systems or super systems to provide that value in more places. So that's it. That's the first pattern. I'm going to do one of these videos for each of the TrizIT patterns. And again, this is covered in the Book Information Technology System Cookbook, which is available on Amazon.com. Thanks.